Hi, everyone, and welcome to today's webinar. My name is Hodan Omar, and I'm a Senior Policy Manager at the Center for Data Innovation. Today, I'm delighted to be hosting this conversation on AI agents, which are systems that can actively and autonomously carry out complex goals in the real world, as opposed to the simpler goals we might expect from something like a chatbot answering a question. For a long time, building sophisticated general-purpose AI agents that can independently plan and adapt to their environment has been a goal for computer scientists. But with recent advances, particularly in large language models, that vision is inching closer to reality. Companies are rolling out early versions of agents that can act as personal assistants and even software engineers. While those capabilities are still evolving, their potential to transform the economy and society is significant. Which begs the question we're all here to talk about. How prepared is policy to ensure that companies can build these systems well and that people can use them in ways that benefit society? To help answer that, we're going to explore three key things. First, what makes a system agentic and what sorts of changes might agents bring that actually matter? What infrastructure and guardrails are needed to support their reliable and scalable deployment? And finally, where exactly does policy need to evolve or potentially stay the course to foster innovation and global competitiveness? Thankfully, I have one of the most well-rounded set of panelists I could ask for. First, we have Ajay Badilia, who is the head of public policy and government affairs in North America for Cohere. Erica Finkel, who is an AI policy director at Meta. Avijit Ghosh, who is an applied policy researcher in the machine learning and society team at Hugging Face. And Helen Toner, who is the director of strategy and foundational research grants at Georgetown Center for Security and Emerging Technology. Thank you all so much for joining me. And a reminder to everyone joining us at home that we will be taking your questions and that you can submit them on Slido. There should be a link to do that from whichever platform that you're watching this on. So with that, maybe we can help set the stage. Helen, you recently wrote a report that says there's no single dividing line for what counts as an AI agent. And you suggest we should instead be thinking about what makes an AI agent based on a cluster of properties. What are those properties? How should we be thinking about this?
Yeah, thanks so much for having us, and it's great to be here, Hodan. So agents, I think like many things in AI, there's no clear, just what exactly counts as AI, what exactly counts as an agent. These terms are often fuzzy. I think at a high level, what do we mean with agents? It's AI systems that are taking actions, that are going out there and doing things, not just chatting to you, not just making recommendations. But yeah, as you say, I don't think there's a clear sort of crisp distinction between AI systems that do and don't count as agents. The set of dimensions that we described in the paper that we published last October was there were four. It was basically an agent. A system is more agentic or more of an agent if it is operating in a more complex environment, pursuing more complex goals. It's independently planning and executing and adapting, and it is directly taking actions. So, those are four things. You could imagine systems that are very high on one or more of them. But maybe just to break down those four. So more complex goals, you could think of a thermostat as a type of system that is acting directly in the world. It's literally turning your heating on and off, but it's pursuing a very, very simple goal. So a more complex goal could be something like book me a flight, or more complex than that, manage the supply chain for my store, or you could go even beyond that. Complex environments. So this is we have a lot of sort of basic AI agents that operate in very simplified environments like games. So you could have a chess playing agent that is sort of playing directly, but the environment is very simplified. It's just 64 squares. There's certain pieces, certain rules, very sort of clean, as opposed to the kinds of agents that companies are starting to deploy nowadays that are able to operate your whole web browser, for example, or potentially even operate your whole computer. And that's just a much more complicated, complex environment. The third one, independently planning and adapting. This basically is this is not a system that is carrying out sort of a pre-specified set of steps that you have just given it. We have lots of computer programs that do that, and they can do very sophisticated things. But if they're just carrying out, instructions that humans wrote, that sort of isn't necessarily a particularly agentic system. And then the final one, directly taking action. We've really covered that. This is not just a chatbot that is making a recommendation. It's not just an image classifier that is giving you a label for your image. It's something that is actually going out and interacting in some real way with some system that you care about. So that's the way that we broke it down.
That's super helpful to think about. Avijit, you've also been thinking about this, and you've written that once something crosses into being an agent, it can still vary in many ways. What are those ways? What are those dimensions that you've been thinking about?
Yeah, so we have a paper called "Fully Autonomous Agents Should Not Be Developed," which was quite controversial, the title is, but it is still a position paper. We actually, okay, So, I mean, we first went online and saw what people are calling agents as, and the field of definitions out there was wild. Like it can be anything from something that performs a web search to like a fully humanoid robot. So we really like looked at all the definitions, and we came up as our definition as computer software systems capable of creating context-specific plans in non-deterministic environments. It's very similar to Helen's definition, but also there are so many things that vary with what agents can do and cannot do. There are different action surface options, adaptability, different numbers. Is it a single agent or multi-agent? What even defines an agent boundary? Can you call a swarm of agents its own agent? Which, like, some people try to define agents as human-like versus not human-like. That doesn't really work. We have our physical bodies as the border for us being an agent, but doesn't really work for AI agents. What kind of domain specificity does the agent have? Are they interoperable, and so on? So ultimately, for our paper, we just decided to focus on the word agent itself. So in our opinion, agents have agency. Autonomy or various levels of autonomy are very different from automation. So we found out that all of these things that people are thinking about and trying to call as agents are effectively, pipelining or making things automatic. That is not necessarily what we think of as something having agency. In our opinion, again, for something to have agency, you need to cede some amount of human control. So the ultimate dimension that we ended up looking for in the paper is who is in control for a function happening. This is a spectrum. We have 5 points in our paper. We go from simple processor where the human does everything. The model is just a program, or the agent is just a program. Router, where the model determines basic program flow. So the human has defined how these functions will be done. The system just chooses when, which I guess is where the thermostat would come in. We have something called a tool calling agent, or level 3, where the human defines what functions are done and the system chooses how. So it has some more flexibility. We have a multi-step agent where the system chooses what to do, which tool to use, when and how. This is probably getting into the realm of what we think of as like Manus AI, which goes online and chooses to use whatever it finds on the internet. And finally, we have this hypothetical fully autonomous agent, which is a system that can do anything it wants, does not have any human supervision. And we think that is like sort of the levels that one should think of in terms of agency.
Thank you. Clearly, there's so much to think about in how we define these systems and how we identify these systems. Erica, maybe you can help ground us a little bit. What can agents actually do today? What is the kind of state of AI agents now?
Yeah, thanks for having me here. I'm very excited to be amongst the distinguished panel. So in terms of the uses I'm excited about, certainly at Meta, we're focused on the consumer, as will be no surprise to folks. And so we're already building AI tools that are easy to use, and that, like, say, the smallest business with just one employee can activate an AI to provide quick support or help them drive sales. And I think the opportunities for agents to support in all aspects of that kind of small business work or for an individual creator is something that I look forward to. To your question specifically, where we are today versus where we'll be is an important distinction. And I'm not going to make any predictions about specific timelines. I'm not in that business, and I'm not expert enough to be able to do so. But as an example, today we're seeing some agents being used for coding, but there's pretty broad, agreement that it doesn't appear we're as close to agents who are doing all aspects of a job, like programmer or software engineer. And so I think those are the kinds of distinctions that become really important as you're looking at where agents are at and where they go in the future. And taking that as a larger trend, I'm seeing agent uses in specific areas and types of uses that many others have already mentioned, but the ability to deliver end-to-end, when you think about something like booking travel or appointments or planning events or shopping, customer support, researching options across all of the above, A lot of these are obviously much more consumer focused based on the fact that I'm at Meta. But I know that there's a ton of interest in seeing, also from the business side and the enterprise perspective as well. We're already seeing some of the AI applications that help make government services more streamlined and accessible to the public. So that's another area where I think there's a lot to be developed along the end-to-end pipeline, and hopefully, agents can continue along in the trend. But I'm not going to try and predict timelines.
Thank you. AJ, the title of this is, is US policy ready for agentic AI? So, what is the policy angle? Why does any of this matter? What's the value proposition for users adopting these tools and for the broader economic or competitive advantage?
Yeah, and it's great to be here as well with distinguished panelists as well. But I love Erica's practicality, so I'll maybe lead with that a little bit. I think in the AI space, there's a lot of hype. A lot of people talk about, pie in the sky and where are we? And I do think agentic AI is a bit of a paradigm shift, even where we are today and where we'll be heading in the next 5 years or so. It's making AI go from this passive tool, as you said at the start, where you're just going to a chatbot and asking it a question, where it becomes an active participant in the workflow. I think there's kind of three things I think about. First, for the users, second, for the economy, and then obviously third, strategically for competitiveness. So look, I think in short, it's going to advance human capability and in terms of time saved and tasks handled. Even if we're not at a point yet where agents are doing completely end to end, we're already at a point where agents can do small tasks. And if you combine a host of those small tasks together, that's a lot of time saved. On the second part, the economy, there's been a ton of studies done already on higher productivity and new solutions, kind of helping with some of the productivity crises we've seen in the US and in allies across the world. I think a recent study just came out that AI agents are going to increase GDP by something like 25% in the next 10 years. That's a crazy number if you think about the size of GDP growth just generally. And then the third part is, I think it means who harnesses those agents will lead in tech competitiveness in the same way that people who and nations who had early access to the internet were able to leapfrog in some ways, in the 90s as well. So what does that look like in practice? We build agentic products at Cohere. We have a product called North, which is exclusively for enterprise use. And essentially what we've said is, imagine a world where, individuals are overseeing teams of these small little AI agents, right? Each specialize in a small little discrete task, kind of working collaboratively. And I still view that as human-centered development, right? Where these small tasks are automated, but there's still humans in the loop, still have quite a bit of autonomy in terms of orchestrating and thinking through, how they should do these things. But that still can help organizations handle more work with the same workforce, tackle problems that were previously too complex or even labor intensive, a project that you just have never had a chance to do that could help improve your organization's tracking or analysis or efficiency. And I do think it's important to remember the competitive angle here as well. As we think about this, I think, as I mentioned on the internet portion of this, I think China has seen this. There's been a huge conversation about Manus. I think it's been mentioned 3 times already in this panel at this point. And once Manus came out, right, the Chinese government and CCTV essentially have been showcasing the agent nonstop in the country. And so it's been interesting to see how they've fast-tracked regulatory approvals for the company's products. It's been interesting to see how they view that as a strategic advantage. And I think in some ways, those state-led efforts highlight the importance of agentic AI to organizations, to the economy, and really how countries and nation states are viewing this paradigm shift that we're in right now.
Thanks. I think that kind of sticking on that idea of practicality, I'd like to shift a little bit to talking about how do you actually make these work, right? What does US policy need to do to make these agents happen and be deployed? Erica, some people are saying we need an entirely new internet infrastructure for AI agents. Help us with that. Is that true? Why not?
Yeah, happy to take that one, and happy to hear from others if they want to chime in on any of it. But I'm going to start with the user interface side, which will probably be most familiar to everyone. So AI agents that navigate the web now, or computer use agents, they're essentially simulating, right, how a human would interact with the interface. And some people are saying that user interfaces are going to change as a result of more and more of this online activity and computer activity being conducted by agents. So an agent is going to optimize for what a resource does, as opposed to how it's designed. In the same way that humans react to the web page design, an agent might not necessarily be optimizing for the same thing. So some people are saying the visual aspects of the web maybe become less important. Without going as far as to say, it's going to completely overhaul the way our user interface is right now on the web and on existing computers. I do think there's a lot of opportunity in that space. If you think of multimodal AI together with AI agents, the opportunity to speak to an agent, to have the agent execute something instead of browsing around the web. It frees people from keyboards. It could potentially free people from crouching over their phones. And so it could be a great accessibility improvement from disabilities perspective. I think there's a lot of opportunity in the space of how humans are going to be interacting with those kinds of interfaces, and how agents are going to be changing those interfaces. And then if you're thinking about the infrastructure, I'm not positive I've seen anything so far that really points to, yes, the internet itself needs to change, and we shouldn't reinvent something that works. So if assuming internet protocols that we have today will probably work for AI machine learning processors and quantum processors, I'm not sure that as much needs to change there. But then you get to the sort of higher layers of architecture, we'll probably need some standardization. And the common example of this that everyone here on this panel is going to shake their head about is multi-agent interactions, right? So if two agents are interacting on a task, they need to have a standard sort of vocabulary in order to be able to do so. They need to be able to avoid errors and misunderstandings across those two agents. And it's helpful and similar to, how, I guess you could compare it to how humans are optimizing prompts today in the ways that they're interacting with AI. A similar type of vocabulary needs to happen between agents in order to help them interact and be efficient and actually perform the tasks effectively on behalf of humans. So overall, I think maintaining an open and interoperable AI infrastructure, which is a load of words to say together, is going to be critical towards achieving a lot of the multi-agent interactions. And for me personally, I work at Meta. I work on general purpose AI and AI for consumers. So what I'm about to say is probably less my area, but if you think about all the different types of developers and vendors who might create specific agents, as others are doing here on this panel, specialized tasks that need to be able to really be specialized in an area like energy or healthcare or whatever the specific sector might be, medicine, science, material science, something of those sorts. A deployer in those fields is likely going to need multiple different agents from different vendors in order to optimize for whatever their complicated tasks are and in order to be able to innovate there. So I think that's why folks are focused on multi-agent communication, and it's an important area for interoperability and communication.
Thanks. Helen, your thoughts on the infrastructure question, needs, challenges?
Yeah, I think I agree with Erica that I don't know that we need to rework the whole internet, but I do think there's probably a lot of new things that we're going to need to build, and that will be built, right now are sort of being figured out on the fly, and we'll see, if that works or not. It's maybe helpful to step back a little bit and just talk about where we're at with agents and where we might be going if you just extrapolate a tiny bit. So I think right now, I don't know if folks have ever tried kind of language model-based agents, folks listening, but essentially the way they work is it's very similar kind of AI to the chatbots that you're used to, but they're often then connected up with some set of tools, some kind of interface that they can use. So maybe it's they're getting screenshots of your browser and they can determine where to click, or maybe it's they have access to some APIs to handle some specific tools that they can use. And so then you give the agent a task and it goes off and tries to do it. And right now, starting to get to the point where they can potentially be relatively flexible and useful in a number of ways, but also tend to be still pretty brittle and pretty unreliable. So I remember it was about a year ago now, but about a year ago we ran a workshop where we tested this one agent, for example, and asked it to reserve to go to the DC library website and reserve a certain book at a certain branch. We tried this like 3 times. I think one time it got it right, one time it got the right book but the wrong branch, one time it got the wrong book at the wrong branch. So that's sort of that is a year ago, so they've gotten better since then. But I think it's still kind of representative of they can do this kind of thing. It's on the one hand very impressive that works at all, that it does sometimes actually complete the task, but they're not reliable enough yet to be seeing kind of really widespread use. But I think you don't have to extrapolate very far to say that if the companies, building these agents, so including Meta, Cohere, also all the, other top AI companies, if they succeed at making them a little bit more reliable and a little bit more effective, then you could imagine very widespread use both in the enterprise level, also at the consumer level. And what that might mean is that you might very soon have kind of a lot of agent traffic on the internet, essentially. So instead of having, most kind of most actions that are happening, most sort of non-trivial actions that are happening being done by humans, there might actually be quite a a large number of AI agents, especially since one user might be able to delegate to many agents all at once. You don't just have to have kind of one agent per person. And so that's where this infrastructure question comes in: is what might we need to navigate a situation where you might have millions or billions of AI agents sort of operating with infrastructure on the internet that was designed primarily for human users. And so I definitely agree with what Erica raised around kind of multi-agent communications and protocols. Some other things that are kind of under discussion right now are also around how do you think about kind of identifying agents? Should they be tied to an individual human? I think from a sort of governance and policy perspective, there's a lot going for that idea of having each sort of instance of an agent ultimately being tied back to an individual human who's responsible for what happens there with that agent. But technically, how do you implement that? Can you enforce that somehow, or is that something that you just need users to voluntarily do? There's been some really interesting work on this idea of, can you set up something that helps you distinguish agents from humans? It's a really interesting paper on the idea of a personhood credential, meaning something that a human could show on the internet to say, hey, I am a human. This has been verified by some party that you trust. And thinking about how to do that in a way, there's obviously very sort of centralized ways you can do that. Like, the Chinese internet, every user has a government issued ID. And so you can just sort of show that, but that has issues for surveillance and tracking. So this personhood credentials paper was sort of describing some more decentralized, more privacy preserving ways that could work. That's another piece of infrastructure. Maybe one more I'll say, and then would love to hear from others, is should we be thinking about having sort of dedicated channels that are designed for AI agents rather than designed for humans? So we've talked about how at the moment a lot of agents are designed to kind of use interfaces that were intended for humans. But if you think about something like on the road, we have roads for cars, we have bike lanes for bikes, we have footpaths for humans, sidewalks for humans. Would it make sense to have sort of different channels that agents are potentially using that are more kind of tailored to their needs and to the way that they work? I think there's plenty of actually, okay, one last, and then I'll truly yield, which is, I think there's also questions around infrastructure related to how do you sort of track and monitor what agents are doing, and to what extent can you do that in order to, for example, if something goes wrong, so that you have some kind of data or some kind of trace for what happened and how to rectify it, versus are there, there's obvious concerns there around sort of privacy and surveillance and who has access to that data as well. But I think there's important trade-offs that we're going to have to make there.
Thanks. AJ.
I think a lot of good stuff was covered in the last few minutes, but I want to highlight one specific area that I'm surprised was not mentioned, and maybe because we're very enterprise focused, on security, which is a huge area, I think, for agentic AI in particular, that we spend a lot of time on, given that we work with really high complex security environments. Look, AI agents are designed to interact with third-party systems. right, in some ways, or access user data, or even control some specific types of devices. And so one of the areas that I really think there's going to have to be additional effort put in, and we talk a lot about this at Cohere generally, just because that's what our customers care about as well, is how are we recognizing the threat? How are we reporting those statistics on efficacy to block those kinds of attacks, right? What does safety look like? What does security look like? And then just as importantly, what does trust look like, right? And when it comes to those things, there's been a ton of research done on security of AI models and what that looks like, everything from prompt injections to sleeper agents and everything else in between. I'm not going to spend a lot of time on it, but I do think it is an area for industry collaboration, frankly, and perhaps one also for government as well, because security is a cohesive societal thing, but one that is going to be extremely important, especially as enterprises, especially as high security enterprises and perhaps enterprises and government agencies with higher touch impact start thinking about how to adopt these things.
Thanks. Avijita, I want to throw to you next, but another thing that we haven't talked about yet is open source. So if you could also touch on how open source plays into this, especially since we're talking about the security question.
Great. I'm so glad you asked me that, because that is exactly where I was going. So a couple of things. So Hugging Face has this framework called Small Agents, which is our proposed framework for building an agent quickly that does tool use and whatnot. We found a few things work and a few things don't. So I mean, right now people are coalescing around Model Context Protocol as like a shared language between tools and between agents and whatnot. But before that existed, people were like literally just writing, this is a tool that browses the web, give it input in this format and output in that format. And these input and output formats look very different from the tool to tool. So we sort of like standardized, at least in Small Agents, the use of what we are calling as coding agents or coding LLMs. So the actions that the agents are doing are given in code, and the performance is also, unless like it requires an action output, if it requires a code output, it also gives it in code. We ended up using Python for that. And so the agents are capable of running Python code. Now, this is where cybersecurity style protections still matter. So just echoing what AJ said, I mean, there's a rich 30-year history of cybersecurity style protections that should be first and foremost in building new systems like this. So all of the code that we run in our coding agents are run in Dockered, sandboxed environments. We actually don't execute these actions on the open internet. It's still sandboxed, and none of those actions are persistent or permanent. Going back to some of the really interesting things Helen said, one more thing I would like to add. Again, this is a problem that we are struggling with even in like AI systems, especially closed AI systems. Closed AI systems don't really have a way to like do provenance, because if you're using just the API, somebody could just switch out the model in the backend. So version controlling is a huge issue in closed systems. In open systems, you can run these things in sandboxed environments, in fully air-gapped environments. Once you have the model, it's yours. Like you can fully stick to a particular version. So I think when we move this sort of knowledge to agents, for closed systems, establishing some sort of trusted agent ID would be helpful, because you could just switch the LLM out in the backend and nobody knows what happened. Less of a threat for open systems, I think. And finally, the last thing I want to touch on, which again is something that open systems are doing better but not yet standardized, is incident reporting. So I've done some work in coordinated flaw disclosure, which is sort of takes a page from existing CVD or coordinated vulnerability disclosure principles in the cybersecurity world. We are saying that if an AI model behaves outside of its intended scope and intent, that is a flaw and that should be reported in an interoperable manner. Definitely that needs to also happen for agents. Like effectively, when I say this, all of the things that are still unsolved in a non-agentic AI model world needs to be done for agents, because these threats will scale. So, take something very simple like accuracy. One model might have some sort of accuracy on some task. Now, if you break it down into this chain of thought, each step using a particular tool, all of the inaccuracies in those tools will add up to have even higher inaccuracy. So having a centralized reporting system here would be pretty crucial. And finally, I think these tools that are coming in the marketplace, so not just agentic marketplace, but tools that can be used by the agents coming in a marketplace, they also require sort of marketplace security, platform security. We have done some work in this area, so we do scan of all of our models. We have different model formats that are more secure than old school Python pickle style things. All of these things. So how you package tools, sell tools, and upload tools and scan tools for threats will be really, really important once we move to the agentic paradigm in terms of infrastructure.
Thank you. It feels like some of the things that we're talking about in this conversation, like identification, are at the kind of model level or the system level, and then some of the other things that we're talking about, let's say incident reporting, seem more at the system level. How can we sort of think about where these different interventions should take place? You know, what are the most at what level should interventions happen now? Which need to be happen later? How do you think about these sort of different breakdowns? Erica, maybe I can throw to you first.
Sure thing. So starting, I think, backing up a little bit from that specific question, I want to take up a point that was just mentioned, which was around a lot of the sort of existing risks still apply. It's a matter of degree rather than difference. And then it's also a matter of, you know, what is the state of the art that we're thinking about for those risks, and how do we actually apply that in the agent's context? And so I want to first kind of emphasize that at least from my perspective, a lot of existing guardrails apply equally here across model, system, and ecosystem levels. All of the types of guardrails that we're used to talking about, we're used to seeing in the AI community, all of the technical mitigations, whether it's like filtering pre-training data for privacy considerations, or pre-deployment risk assessments, and red teaming and fine-tuning. There's a huge baseline of what everyone is doing that will continue to apply to agents. And so sometimes there's a misperception that we're coming at this all from scratch. It's much more degree, and sometimes there are indeed unique differences. And usually those are around the ability to actually take action, to actually exist in the environment of the web or around somebody's computer. And so really differentiating when those come out and when it's matter of degree has been really helpful for thinking also about the types of mitigations and the types of different layered approaches to be taken. From the meta side, as an open source provider, again, the sort of baseline that we've already built for the AI community, and particularly for developers using our open source models, resources like developer use guides for developers to think through what should happen with agents and special considerations for agents, but also really publishing not just our best practices, but open sourcing tooling to help folks. One of the reasons I didn't mention security previously was because I wanted to talk about it specifically here. So tooling that helps with prompt injection and some of the security risks, really important, and really, something we're thinking a lot about contributing to the community. All of the knowledge that we can garner from our internal perspectives and expertise to help developers there. We already have a lot of open source tooling along this line, so it's just continuing the same of what we've been doing, and then helping across the ecosystem. I think probably the last thing I'll say is that just thinking about the cutting edge of some of the guardrails that we can build from a technical perspective, I think there's a lot of exploration right now about how non-deterministic systems or other types of AI can be helpful with respect to agents, in particular risk mitigation scenarios, whether it is prompt injection, whether it's collection of sensitive information and storage of sensitive information. So also thinking about how different types of AI can interact within some of these technical guardrails.
Thank you. Helen, please jump in.
Yeah, coming back to this question of what do we need to mitigate at the model level versus system level and ecosystem, I think the the starting point is it depends on the question, or depends on the harm. So I think there are plenty of I think maybe that many things can be handled at system level. A lot of questions around user interface, user experience, data privacy and data governance. There's a lot of sort of system level questions there. Thinking about the division of responsibility between an agent and a user, and who is responsible, and how decisions are getting approved, or what is done autonomously. I think a lot is at the system level. Certainly some things at the ecosystem level. We haven't talked that much about kind of potential labor impacts of increasingly advanced agents. That is much more an ecosystem kind of question. There are others. One kind of interesting dynamic that I wanted to just note here as well, though, is I think if we're talking about some of the sort of frontier risks from increasingly advanced AI systems, those are risks where I think the risk is sort of inherent in the model, but to test for it, you need to be thoughtful about the kind of agent scaffolding that you use. So there's been some really interesting developments around, for example, if you have a new model that's more advanced than anything that's been released before, how concerned should you be about its cyber offense capabilities, for example, or how concerned should you be about its level of ability to autonomously sort of to carry things out autonomously, to potentially escape its initial server and adapt in the wild, things like that, which are risks that the big AI providers are testing for. And there's a really interesting set of challenges around what gets called capabilities elicitation, meaning how do you tell how good this model is? It's going to depend a lot on what sort of setup you put it into. And so I just wanted to name that as a sort of interesting question here, where even if you as the AI developer are not necessarily releasing the model in the form factor of a particular system, if you're releasing it in a way where someone else could build it into a form factor, you need to be kind of anticipating that and thinking through what might it be able to do if given access to a certain number of tools, or if fine-tuned in a certain way, or if kind of set up differently than how you happen to set it up yourself.
Thank you. AJ?
I think there's been a lot of great discussion on the system and model layer. I would love to talk about the general ecosystem, and I think Helen actually teed me up really well here, which is this is in some ways not too dissimilar from the model layer conversation we've been having for years now at this point, right? And whenever I talk to policymakers and others, I often say, look, it's important to highlight use case, as Helen just highlighted, which is, what is it being used for? Is it high risk? Is it low risk? What is the deployment context, right? Is it privately deployed? Is it on public infrastructure, or some mix? And what's the access control? So is it public facing? Is it enterprise focused? Is it completely internal? I know that's a lot of specifics, but I think it's very important to think through this, because we've just talked about how AI agents have varying levels of autonomy and operate in kind of different contexts, right? And so not all agentic use cases carry the same level of risk, and it really depends. An agent doing one thing in one environment could be very, very different in another environment based on where and how it's being used. And so, for us, look, we're an enterprise-only company. We're the only model developer that develops only for enterprise. And so it's very different than, say, an open domain consumer agent, right? So the enterprise security agents we work on, right? A consumer agent might operate in an uncontrolled environment, might have to handle unpredictable content, have limited assurances of security. I think by contrast, for enterprise, we're building for security and reliability and compliance in mind, right? And oftentimes built for being behind company firewalls, or in a private cloud or on premises. And I think that really matters for a number of different reasons, right? For example, data privacy is a huge part of the conversation we've already had today. In an enterprise, especially in a closed or completely firewalled environment, agents have to operate without sending that data back already as it is, right? And sharing and having information or access to information that's already in the enterprise environment is a similarly really important task that I think is essentially critical to how you operate an agent. But I think the third and most important part of this is there's a huge emphasis when you have an enterprise use case on secure APIs and identity management and access controls that already exists in an enterprise use case, right? Because you want the agent to know who the user is, right? What the roles and permissions are. You don't want the CEO to have the same access as the intern and somewhere in between. And so, the agent essentially becomes an extension of the enterprise's IT system. So subject to the same security and audit requirements that come along with it as well. And so I think this is where it gets very complicated and why we often say it's not a one size fits all, right? You can't just have one rule that fits it for every single agent out there, and why a sectoral approach where it looks at what's the use case, what's the field that we're in, where we're working. I think there's some agent level stuff we certainly need to talk about. We've talked about it today, but it's extremely important as we think about the space as well. And Helen put it very eloquently, right? Where it's being used and how.
Thanks. I think one thing that tends to also cut across and definitely comes up in these conversations is always around sort of liability and how to address liability challenges, and certainly seems to be one that I think policymakers will be concerned. Even we already have this kind of liability question. What should be on the deployer, what should be on the developer in existing AI systems. That will obviously change as we think about agents. And Avijit, you've really argued for preserving a certain level of human agency when designing AI agents. What kinds of decisions or settings do you think matter most? How are you thinking about the liability question?
Mm-hmm. Thank you for that question. I've been thinking a lot about situations where humans are the most vulnerable. So in our paper, we talk about the 1980 NORAD incident where, during the Cold War, there was this false alarm where someone thought that Russia had sent nukes towards us, and it ended up being a computer error, which was just found out by human operators working on the field that day. So because there were multiple levels, there were redundancies built in the system, they just did not rely on one signal, but then had human verification before pressing the button. That is sort of what I think about in terms of the most vulnerable environments where human precision, or at least human presence, is still needed, because at some fundamental level, we don't trust agents the way we trust humans. Trustworthiness is a whole philosophical debate. So I have been thinking a lot about war and agentic uses in war. Also, other areas where humans are vulnerable are, caregiving robots. So Japan has done a lot of investment in caregiving robots because they have a demographic crisis. Their population is aging. We don't really think about what level of trust and access should be given to a robot or to a model when it is taking care of another human being. Professor Alison Gopnik from UC Berkeley has some really interesting work on raising a robot like your own child, to sort of impart values over a lifetime instead of having something initialized with a set of values before the tables turn and it does something, in terms of then who do you hold liable? If you're raising the robot with your own values, then when the robot is taking care of you, those are your values. So that sort of builds in that liability from the receiver's perspective. And it's really complicated. I mean, think about autonomous vehicles driving on the road. When humans don't know what the correct answer is to the trolley problem, what sort of answer do we pre-feed to the car in terms of deciding when a situation like that occurs? So I definitely agree with all of my co-panelists here in that this is extremely complicated and has to be decided on a case-by-case basis, and has to be proportional. So, around SB 1047, the whole debate was model developers should not be held liable for every bad thing that happens down the line. Similarly, in this case, I think we should have proportional legislation in terms of liability. We should see at what level of the whole pipeline who had control. And, so who made the system, who made the model, who put it inside the system, who developed the different tools that the agent was using, and ultimately who was operating the agent when that incident happened. And at any of these points, if you don't have one or more human beings that don't have, human control or human agency, that's bad, because who do you hold liable? We don't have a legal system. We don't have a separate constitution for robot rights. And if we are moving towards a world where robots or agents coexist with humans with the same level of agency and the same level of autonomy, short of creating a permanent underclass, I don't see how the current legal system is capable of holding non-humans liable for the harms. So definitely, I will continue to argue for having some level of human control at every step of the agentic workflow.
Thanks. I want to pick up on the tracking part of what you just said. Before I do, just a reminder to everyone who's joining us at home that you can submit questions to our audience via Slido from wherever you're watching this. Oh, Erica, please jump in.
Just a couple of quick points on that. I do think one of the comparisons that we're seeing a lot, and analogies do matter in this context, is to the autonomous vehicles space, and to the excellent points that I think Helen and AJ were previously making. I think there are some parallels to be drawn with respect to the autonomy of vehicles, but it's also interesting from the liability perspective. I think we're much more, it seems like we might be much more at the stage of, when it comes to sort of the tort system and things like that, of when vehicles were actually being developed. Like autonomous vehicles have a single purpose, and that is to drive, and that is a specific domain. If you're thinking about general purpose agents, it could be quite different. And if you're thinking about how liability will develop and play out, certainly, while we have a well-established set of safety practices and security practices around AI generally, I think the autonomy piece is where we will see much more, that Helen was talking about, is where we will see much more sort of standardization and potentially like development over time as we begin to find conclusions from a lot of the research in that important research in that space. The other thing to note with respect to some of these different contexts, caregiving contexts versus others, is that helpfulness somewhat changes across these contexts, and what reliability looks like somewhat changes across contexts as well. Which might come into play. So if you're thinking about a caregiving context, it's not really often a context in which you're desiring an agent to actually make a specific recommendation or take a specific action without checking back in, with the human's desire. That might not be the same for an enterprise agent deployed to do a repetitive task again and again and again. And so the human in the loop becomes a very interesting concept of how is that personalized to different contexts and to different, not even just contexts, but users potentially, and to what their individual needs are, what their individual preferences are, and how that will also play out with respect to ultimately, I think it's actually an opportunity space for agents where there is a lot of opportunity for more preferences to be taken into account rather than a standardized set of controls that has to meet all sort of user needs in a consumer context.
I think this also comes back to your original statement that it's pretty hard to see how things are going to develop and do timelines, but in order to do effective policy, it feels like we need to better track where these systems are going, what context they're being used in, how effective they are. Helen, I know you've done some thinking about sort of this question of how do you kind of track where we're going. Any thoughts on this?
I think it comes back to what is a bit of a refrain in AI policy right now, which is the importance of transparency and the value of transparency from the companies developing these systems. I think there's been a lot of a flurry of activity in AI policy the last couple of years, and a lot of different perspectives, arguments, fights. But one thing that I think many perspectives can come back to and can agree on is that more transparency, more disclosure can be really, really helpful here. So for the companies that are developing and offering these systems, disclosing more information about what, how did they build them? What tests have they run on them? What are they building next? What are these systems designed to optimize for? What are the, what's the set of specifications that they've been built to? And then I think relatedly, this is not quite sort of transparency, but is very related in terms of having access to information. Another comparison that came up in this workshop that we ran last year that I thought was really interesting was this idea of sort of collecting ecological data, meaning if you think about the environment, we don't just put regulations on how much a chemical plant can emit, or them having to measure their own releases of chemicals, we also can put a monitor in a river and just say, like, what's going on in this river. Or we can put an air quality monitor on a building and anywhere we choose. And so the equivalent here, the idea here is, what sort of ecological data can we gather about how agents are being used? So this could take the form of surveys of workers, of how they're using AI, AI agents or AI more broadly. Could take the form of, I think a particularly potentially sensitive use is AI companies using AI agents to accelerate their own R&D. Could we be, taking measurements of that? I think that's this whole area of kind of transparency, disclosure, better sort of measurements of what is going on is very helpful for sort of that doesn't directly solve any particular problem, but it puts policymakers and the public and civil society in a much better position to be able to kind of understand and respond as the space changes, as it tends to do, very quickly.
Yeah. AJ, your thoughts on this?
Two things I want to add on here. I think number one, the AI value chain conversation, I think, as folks know, has been a pretty contentious, well, not contentious, but a pretty lengthy documented process that's been occurring for several years at this point. And I think it's really interesting. I think as a model developer, one that it's very different. We don't just release our models and put it out. We work really closely with our customers, right? And so a lot of our work is really just sitting down with the customer, sharing, our work on our security assessments, our transparency, our practices on quality and integrity of our training data, including data lineage as well, to a point where, we're sharing core processes and the details of our methods, right? I think that kind of partnership, as you start moving into some of these use cases that we're discussing, is going to be absolutely essential, because again, this is going to be a shared process across the entire value chain. It's not just model developers; it's a host of questions that come about it and how you use it. But I'm also kind of want people to be aware, we have a lot of existing laws on this already as it is, right? Like we have a number of sector specific standards that already exist that talk about product liability and professional malpractice. And I think as you think about, for example, in the healthcare context, right? If a doctor is using an AI agent to, help them prep for a patient visit, right? Whether it's, getting a medical record together and it's, thinking through whatever their allergies might be to doing the billing there, what kind of transparency does that doctor have? What kind of ability to check back and click through using, say systems like retrieval augmented generation or something else to have an understanding and a level of confidence and trust in the system, which would comport itself, I think, to existing laws already in the system, right? And so I think we don't have to rebuild the wheel in some ways. All right, what we have to do is look at where existing laws help and currently integrate. Try to ensure where there is lack of clarity, providing clarity to the people who are actually putting these systems into place on the day-to-day. And then where those first two don't match, I think that's the place where we need to start talking about additional laws and regulations. But I just want to be careful here that AI is not, a one side, just this one use case situation, right? And I feel like I keep saying this over and over again, but it's the operating system for the world essentially. Right. And you can't really create a one size fits all for it.
Thanks. Abhijit.
Yeah, one small thing I want to add here is about access. So I feel like a lot of regulation, a lot of institutional attention goes towards frontier models and towards hypothetical use cases. When you actually see what kind of models are being used and what the use cases are, they look very different. So Anthropic had this paper called Clio, where they had a privacy-preserving way to see how people were using Claude. And they found out that 80+% of their use cases are just people using it to write code, right? Yes, some people were using it for medicine. Yes, some people were using it for, some sort of reports. But like, given that the vast majority of that model was being used for coding, I feel like a proportional governance response would be to see whether that code generator is malicious, what sort of cybersecurity implications there are, and so on and so forth. Same thing for frontier models, right? A lot of policies written for frontier models, but then again, as Hugging Face, as an open platform, we do have the benefit of seeing what kind of models are the most used. There was a ton of talk around DeepSeek R1 being like, the one thing that ends all. Ultimately, DeepSeek is 405 billion parameter model that most people cannot use. It's locked behind an API. You can't run it on consumer hardware. At Hugging Face, the vast majority of used models we have found are small models. 7 billion, 2 billion, whatever parameter, and all of this data is openly accessible. You can go to the Hugging Face year in review paper. The other thing that we have seen drives usage is also documentation. So you can write laws that sort of will restrict, innovation, but ultimately, is that going to impact people safety, or is it going to impact innovation? So we saw that well-documented data sets and well-documented models via dataset cards and model cards are also the most used. Data sets with filled-in dataset cards drove 90% of the data download on Hugging Face. Similarly, if you build a sketchy agent and put it out there, it is less likely that it will be being used by somebody for malicious usage, while more documented and more accessible agents and tools will likely be the most used in the ecosystem. So I think that's where policy should look at in terms of signals on what models and what tools are being the most used and how they're being used before thinking about new policy.
Thanks. And just to think about, outside of kind of US, well, it's still US policy, but thinking outside of borders, as agents scale globally, is there anywhere where it's best for us to work with our international partners? Anybody have thoughts on that?
I have one quick thought, and maybe then I can pass on. I keep thinking about the incident that happened in Myanmar during the uprising and how Facebook had no way to sort of moderate because they did not have enough moderators speaking the language. And as moderation is now sort of being increasingly handed over to LLMs to at least make a primary determination before, people step in, I think about, agents trained on particular languages talking to each other to prevent these kinds of future disaster. So really like sort of interoperability on actions, but yet localized to different parts of the world would be really cool to see. So that's one area where alignment must be needed.
Thanks. And we have one audience question. Would there be any value in requiring AI agents to identify themselves, such as in interacting with humans, and if it's not obvious with other agents? Helen, you have thoughts on this?
Yeah, I mean, I think the short answer is yes. It would be very useful to have either sort of hard rules requiring this, or at a minimum, kind of a soft norm where companies build their agents in such a way that this works. I know there's been various attempts to make what get called bot or not laws, meaning laws around AI systems having to disclose that they're AI systems. And I think to the extent that the sort of dream of having more and more agents doing more and more things comes true, I think it'll be quite helpful and quite important for it to be straightforward to determine. Maybe it doesn't necessarily have to proactively disclose, but there has to be an expectation that if you ask, a system will tell you that it's an agent, or maybe there are sort of simple ways to also have them proactively disclose. But I think certainly having access to that information and it not being confusing, not being concealed, whether what the thing on the other side is human or AI is potentially quite valuable.
Thanks. And Erica?
Yeah, I'll take a last little bit of our time to add on to what Helen said. I think maybe I have a similar agreement with maybe a slightly different take, which is like, we don't know all the use cases yet. And there is quite a potential that some user desired use cases would be the opposite. And so before we jump to requirements, we should be thinking about if an agent's drafting an email and potentially somebody, it's to my family member and I actually don't want, and it's sending it for me, and I actually don't want that family member to be understanding that that's my agent. Is there some way of, I think Helen, you proposed like, maybe it's more like soft norms where then also the agent identifies itself if it's asked or something of the sort. So before we get into sort of like hard requirements that then end up sort of, interacting in ways we didn't foresee with use cases we didn't foresee, I think it's really important to be understanding how people are using and deploying the technology and what, the user research that we every day perform to understand where there's value and then where there's also trade-offs. trade-offs with some of those use cases. That is all to say that there are obviously a lot of potential misuse cases and a lot of risk there. So I don't want to, say that those aren't important or that they shouldn't be addressed, but just also that you have to be thinking about what the user has in mind as well in those kinds of contexts, especially in consumer contexts. I will just emphasize there's a lot of existing law in this area. I think AJ said it, like there's a ton across contracts, torts, consumer protection, sector-specific regulation. I mean, it's everywhere. Helen's paper does a great job of outlining a lot of it. And so it will, I think, seeing how all of that comes to play with respect to agents and AI more generally, and understanding in particular with this capability, as you so well outlined it, and some of the others so well outlined it at the beginning, is a really important part of understanding where to go from here and really applying what exists in the best ways possible for the new and developing technology.
Thank you very much. And I know we could probably go for another hour, but we are running out of time. So I want to thank you all for joining me. This has been an incredibly rich conversation. I'm sure that I've learned a lot, and so has our audience. So I really want to thank you very much. I'll probably have to reconvene you in a couple of months anyway for a follow-up. So thank you so much. And thanks to everyone who watched at home.